So number 4 from last night's homework is talking about taking a rectangle and inscribing it in a semicircle with a radius of A. So here's the semicircle, and you'll note that I've drawn it on the coordinate axis. I don't like how I did that rectangle, though. That looks a little bit better. Not really, but it's acceptable at least. You should know that the equation in a semicircle is y equals the square root of the radius squared minus x squared. That just comes from x squared plus y squared equals your radius squared. If you solve that for y, you got y equals the square root of r squared minus x squared. So since our radius is a for this particular problem, we're just replacing the r with an a. The positive square root gives us the upper half of the semicircle, and the negative square root gives us the bottom half of the semicircle. So what we need to do is we need to figure out what the length and the width of this are. So we know that we're going over x units from the origin, which means that we're going up y units, or root a squared minus x squared units for the height of this rectangle. And since semicircles are symmetric and the rectangle should be the same on both sides, this ought to be a base of 2x. So we should have the area of the rectangle is 2x root a squared minus x squared. Everybody good with that so far? Julianne, especially since you asked, are you good with that or no?
Yeah, I get it.
Okay. So then to figure out when that area is at a max, we got to take a derivative of it. We'll keep in mind as we're taking that derivative that a is just the radius of the semicircle. That's not changing, so that's a constant. So a squared is also a constant. So when we take our derivatives, we want to keep that in mind. So product rule here gives us 2x and then times the derivative of root a squared minus x squared, which is 1 over 2 root a squared minus x squared, and then times the derivative of the negative x, or the a squared minus x squared. The a squared part is 0, and the negative x squared is a negative 2x. And then plus the derivative of 2x, and then times root a squared minus x squared. We can cancel out these 2's. And if we want to get a common denominator, we'll multiply both top and bottom of the second one by root a squared. Oops. Minus x squared. And so what does that end up giving us here? It gives us a negative 2x squared. And then here we've got plus 2 times the roots cancel out. So a squared minus x squared all over root a squared minus x squared. Everybody good with that?
Yes.
Okay. Simplifying that out, negative 2x squared and then minus another 2x squared. So that's a negative 4x squared plus a 2a squared over root a squared minus x squared. So there's our derivative. Root a squared minus x squared. So there's our derivative. We have to figure out when it's undefined. So it's undefined whenever root a squared minus x squared is equal to 0. But that wouldn't make any sense in the context because that would mean that the height here is 0, and then we're not actually going to have a rectangle. So then we just really need to figure out when is the numerator of this equal to 0. So that's when does negative 4x squared plus 2a squared equals 0. And if you solve that, you get 2a squared equals 4x squared. Divide by the 4. You got a squared over 2 equals x squared, or x equals a over root 2, plus or minus a over root 2, but a negative length isn't going to make sense either. Everybody good so far with that? Julianne, good with that?
Yeah.
Okay. And so then the question is, how do we show if this is a max or a min? And so we have 2 options. One is to make a sign chart and plug in something more than a root 2 and something less than a root 2. That's a little bit of a pain. So is taking the second derivative. But let's just, for the heck of it, use the second derivative test. So this was our numerator, right? And our denominator, we have negative 4x squared plus 2a squared over root a squared minus x squared as our first derivative. So we'll take our second derivative. So we'll take the derivative of that. And have a double prime is equal to the denominator times the derivative of the numerator. which is just negative 8x because the 2a squared is a constant, minus, and then the numerator, negative 4x squared plus 2a squared times the derivative of root a squared minus x squared, which was 1 over 2 root a squared minus x squared times a negative 2x. And I'm just going to put a 2x because if I have a negative, I can change that into a positive. Everybody good there?
Yeah.
And then the denominator is just root a squared minus x squared squared, which is a squared minus x squared. So now we're going to evaluate that at a over root 2. So we've got a lot of these a squared minus x squared terms in there. So let's just figure out what is a squared minus x squared, so we can just kind of plug those all in and not have to redo it every time. A squared minus x squared is a squared minus a squared over 2, or 1/2 a squared. So anytime I see an a squared minus x squared, that's just 1/2 a squared. So the square root of this ought to be a over root 2. And then the negative 8x ought to be negative 8a over root 2. And then we've got a plus. And if I distribute the, well, I could, before I distribute anything through, this 2 and this 2 can cancel, right? And so we'll distribute the negative, or sorry, the positive x through there. So that's going to give us, if I distribute that x through, that's going to give us a minus 4 times x cubed. And so x cubed is a cubed over 2 root 2. And then plus a 2a squared x, which is plus 2, and a squared, and then x is a over root 2. And then that piece of it is all over and root a squared minus x squared, which we already figured out, that's a over root 2. And then it's all over a squared over 2. Everybody good with that so far? A little bit messy, but doable, I think. So I'm going to take this little slow here. We got negative 8a squared in the numerator over 2, which should be negative 4a squared. So I'll give ourselves a new page for that. We got negative 4a squared. And then here we've got minus, let's see, the 4 over the 2 cancels, right? So that's a 2a cubed over root 2. So minus 2a cubed over root 2. And keeping in mind that's all going to be over this a over root 2 still. And then this one is 2a cubed over root 2. So plus 2a cubed over root 2. And then down there in the denominator, we had an a over root 2. And then that's all still over a squared over 2. Everybody good?
Yep.
This piece right here in the numerator is what? 0, which means that I can get rid of all of that. That's just 0. So all I've effectively got is negative 4a squared divided by a squared over 2, which is the same as times 2 over a squared. The a squareds cancel and you get negative 8. Negative 8 is less than 0, which tells you that that was a max. Good or no? Questions on that? Everybody okay with that?
Yeah, it makes sense. It's just a lot of steps, and I think I just got really confused in all of it when I was trying to do it by myself.
Gotcha. Yeah, it's a lot of algebra, a lot of stuff to plug in there. So, any other questions from the optimization last night?
When for this question, especially when you're calculating the second derivative, does College Board want you to actually find a value, or can you just say, like, if you can tell, you can just be like, oh, if you plug in this really small number, it's negative, and you just say it's negative, or do you have to actually calculate it?
I mean, you need to physically show that it's negative. Yeah, you got to have some proof that it's negative. You can't just say it's negative.
So there won't be situations where that, like, a won't cancel out and you can't Are there
Correct,
any?
Yeah, I mean, theoretically, there could be a problem like that, but they won't do that to you on the AP test.
Okay.
They'll make it so that you can show whether it's a max or a min. For sure. Any other questions on that one or anything else on it? From the optimization? The basic premise of this problem is we've got a fence stretching, or we got a ladder stretching over a fence. The fence is 8 feet tall, and there's a 1 foot gap between that and the building. We want to know the shortest ladder that'll reach. So the way to set this up is we want to label these as like X and Y and say we're looking for the minimum of Z. And so we can use the Pythagorean theorem with Z squared is equal to X plus 1 squared plus Y squared. And then from there, we just need to figure out what Y is in terms of X. And since these are sharing this angle and they both have a right angle, then we can see that these are similar triangles. And so we can set up a ratio of 8 to X is equal to Y to X plus 1. And that Y is equal to 8x plus 8 over X. So we can replace that there. In fact, what I would do is I would write this as 8 plus 8 over X, because that's going to make life a little easier later on. And we get Z squared is equal to, in fact, I'm going to distribute that all out right now, X squared plus 2X plus 1 plus, and this one is 8 plus 8 over X squared. And I'll deal with the distributing that in a second. Everybody good with that so far? Okay, so one thing that we'll want to note for problems like this, it's often really convenient to not have to square root this. So we're looking, all we're doing with our derivative is finding out when, what X value makes this thing be at a max or at a min. And so the X value that makes something's square equal to its max or min is the same X value that makes the actual function equal to its max or min. So I can just minimize Z squared because the X value of the min of X, of Z and Z squared should be the same. And so rather than having to go through and take the square root and have a really unpleasant, complicated derivative, we can just take the derivative of this, which is a lot simpler. So we're going to rewrite this now as Z squared is equal to X squared plus 2X plus 1 plus 64 plus 128 over X plus 64 over X squared. And the 64 and the 1 can be combined together, but it doesn't really matter because when we take the derivative, we're just going to say Z squared prime. The derivative of that ought to be 2X plus 2. This is minus 128 over X squared, and this ought to be minus 128 over X cubed. Everybody good with that so far? So it's undefined when X is 0, which isn't going to make a lot of sense because then my ladder would have to be straight up and down against the fence, and that's not going to reach the building. So to figure out when it's equal to 0, we'll get a common denominator. So we'll multiply these first two by X cubed over X cubed, and then the third term by X over X. So we're going to get 2X to the 4th plus, what was the other one? It was just a 2, right? So plus 2X cubed. And then this one should become minus 128X. And then the last one was a minus 128. And that's all over X cubed, but all we really care about is when does that equal 0. So when is the numerator equal to 0? You can divide them all by 2 to give yourself x to the 4th plus x cubed minus 64x minus 64. And then if you factor this can be factored by grouping. So this becomes x cubed times x plus 1 minus 64 times x plus 1, or x cubed minus 64 times x plus 1 equals 0. So x equals 4 or x equals -1. And -1 doesn't make a lot of sense. Only x equals 4 does. And if you were to do a sign chart with 4, and obviously we're going to have to stop at 0. We're not going to have it be any less than 0. So if we plug in something like 1 to our derivative, the numerator of this is clearly going to be negative, and the denominator is going to be positive. So the function is decreasing. And if you plug in something greater than 4, it's going to be increasing. And so you'll see that we have a minimum length at x equals 4. And all you then need to do is go back in and plug in 4 for x in here. If x is 4, then y ought to be, looks like 8 plus 2. So y equals 10 if x equals 4. So we've got 5 and 10 as our 2 lengths. And so using the Pythagorean theorem again, we get 5 squared plus 10 squared equals z squared, or z equals root 125, or 5 root 5. Does that make sense? Or no? Everybody good with that? Claire especially good with that?